Hey, welcome back. In the previous video, we have seen the predicate and its few examples. In this video, we will see the concept of predicate chaining. Now, predicate chaining means combining multiple predicates into a single predicate. So let's say if I have a predicate which will check if the given number is greater than 5 and another one which will check if the given number is even. So if I want a number which should be greater than 5 as well as should be even, what should I do? I will combine these two predicates into one, and that's what the predicate chaining concept means. So basically we have three methods which will be used for predicate chaining. The first one is negate, the second one is add, and the third one is or. Now you may have studied the logical gates in your universities. This method represents the same concept. Now we will see the negate method. Negate means logical negation. So negate method will return a predicate that represents the logical negation of this predicate. Now this predicate in the sense, if I have a predicate P1 and if I have invoked the negate method on P1, the returning predicate will represent the logical negation of P1 as I have given in the example. So let's see its example in the Eclipse and you will understand it better. So let me create one class and I will give it a name test. Let me add the main method. Okay. So I will create one array, int array r, and let's take a number 1 to 10. Okay, and now I will add a predicate integer, let's say p1, and I will write a lambda expression here. So if you are facing any difficulty writing lambda expression, I will recommend you to check my first video. I will give the link in description or in I button. So we are getting parameter I, and let's say I gives I greater than 5. Okay, let me import the predicate by pressing Ctrl 1 and we will see the possible options. And let's import the predicate from java.util.function package. Save it. Okay, so we have a predicate p1 which will check if the given number is greater than 5, and let's create another predicate, same integer, give it a name p2, and now we want negation of p1, so p1 dot negate. Okay, and let's test this negation is working or not. So we will write a simple for loop for iterating over an array, and int I ar sys out. So I p2 dot test, I will pass I here. Okay, so let us check this for p1 also, so that we can compare both the results and it will help you understanding it better. Add a simple sys out statement so that we can separate the results. Let's make it p1. Now it looks fine. Okay, fine. Okay, let me run it. So press F11. Okay, so we will check the result for p1 first. So what does our predicate p1 means? Check the given number is greater than 5 or not. So until 5 it says false, because 1 2 3 4 and 5 is not greater than 5, and as soon as we go till 6 it says true. For all 6 to 10 it says true. Now this is normal predicate p1, and at P2 we have taken a logical negation of P1 dot negate, and when we invoke the test method on P2 it is giving opposite results. Now what our P1 means, if the number is greater than 5, and the logical negation of is the check if the given number is less than 5 or equal to 5. So you can check till 5 it is printing true, and after 5 it is printing false. So this is logical negation of the P1, and that's why you can see both the results are opposite. So this was the example for negate method. Let's check another method and we will see its example. Now we will see the AND method. AND method represents the logical AND operation. So it returns a predicate that represents a logical AND of this predicate and another one. So you can check in the example that P1 and P2. So it will return a predicate that represents the logical AND between P1 and P2. So there is a second point which will say, like, when evaluating the composed predicate, if this predicate is false, then the other predicate is not evaluated. So if you have studied the AND operation, you know that if we need both the P1 and P2 as a true, if either of it is false, the result will be false always. So the second statement says if the P1 is false, there is no need to check the P2, because irrespective of P2's result, combined result will be false always. So let's see an example for it and you will understand it. So okay, we will modify this example only, and let me clear the console. Okay, so here we will create one predicate integer, and let's give it a name P3. And in predicate P1 we are checking if the given number is greater than 5. Here we will check if the given number is even. So I modulo operator 2 equal to 0. Okay, and we will create another predicate integer. Let's give it a name P4, and now here we will do the AND operation for P1 and P3. Okay, so we want a predicate which is a logical AND operation between P1 and P3. That means my number should be greater than 5 as well as it should be even. And let's iterate over it. So here we want P4 and we are passing the I, iterating over same array. Okay, so we do not want to see the results for this predicate, so I will comment it, and let me comment this also, and let's run it. Okay, you can check the result now. So what does our predicate P1 means? My number should be greater than 5. So until 5 you can see that it is false, because when we are doing the logical AND operation, if either is false, the combined result will be false always. So if P1 says check if the given number is greater than 5, until 5 we are getting false, so combined result is false. Now P1 and P3 says check if the given number is even, and we will be checking. So after 5 our first is true, that means 6 is greater than 5, and also 6 is a even number, and that's why we are getting the combined result as true. Now at 7 our first predicate is true because 7 is greater than 5, but it is not a even number, so the predicate P3 is false, and logical operation between true and false is false, because either is false, the combined result will be false always. And that's why you can see for 8 the combined result is true because it is greater than 5 as well as even. For 9 it is false because greater than 5 but not even, and for 10 it is true. So this is an example for AND method. So let's see the remaining OR method. And so OR represent the logical OR operation. So AND method will return a predicate that represent the logical OR between this predicate and another one. So as I have shown you in the example, P1 or P2. So either predicate returns true, the result will be true. And the second point says, when evaluating the composed predicate, if this predicate is true, then the other predicate is not evaluated. Because when you studied the logical OR operation, you know that if the first one is true, then no need to check the another one, because irrespective of the P2, if P1 is true, the combined result will be true always. So let's check this example in the Eclipse and you will understand it better. So we have checked the negate and AND. So here we will check the OR method. Simply take this for loop here and we will create one predicate, integer, let's give it an MP5, and it will be OR between P1 or P3. Now what does P1 predicate is mean for? Checking if the given number is greater than 5 or not. Here you can say line number 11. And now what does P3 means? Checking if the given number is even or not. Line number 24. And P5 is the combined logical OR operation between P1 and P3. And here we will test it for P5. Okay, so we are passing I for P5. So let me comment out this. Okay, let me clear the console and we will run it a little more. F11. Okay, and you can see either is true, the combined result will be getting true. So if number is greater than 5, for number still 5, it is not true, but if a number is even, the combined result will be 2. So 2 is not greater than 5, but it is even, so the result is true. 3 is not greater than 5, also it is not even, so the result is false. Let's say for 6, it is even as well as it is greater than 5, so both are true, no issue, the combined result is true. For 7, it is greater than 5 and 7 is not an even number, but still it satisfies the one condition that it is greater than 5 and the combined result is 5. So for numbers greater than 5, it will be true always, because it always satisfies the first condition. For numbers less than 5, it satisfies the second condition for 2 and 4, and that's why you can see these results. So this was the example for logical OR operation. So hope you understood it, and if you have any questions you can ask it in the comments, no issue. So that's it for this video, and we will see the next concepts in coming videos. Thank you.